Mr. Larkin, I now fully understand how to name ionic and covalent compounds, but I just need to know more. Okay, calm down. I understand that you really want to learn more, so let's just do it one at a time. Okay, let's talk about ionic first. Okay, so ionic crystals, right? Everyone's always asking me to make crystal. Chemistry teacher. Well, now we're talking about ionic crystals. Chemists have studied reactions of unstable atoms on the periodic table for hundreds of years. Basically, what this is saying is that chemists have tried to blow things up for hundreds of years. Yep. One of the first types of reaction to be observed was the reaction between metals and nonmetals. When a metal is brought in contact with a nonmetal, there's often a flaming or explosive reaction that is exciting and sometimes dangerous, usually dangerous. When a metal reacts with a nonmetal, an ionic crystal is always produced. So metal, nonmetal, ionic crystal. The most well-known example is ordinary table salt, sodium chloride. You eat this stuff, which is produced when sodium metal is exposed to chlorine gas. So if we take Na and we mix it with chlorine gas, we get NaCl. So that's what we have here, solid sodium chloride crystals. Let's see, highly magnified image of sodium chloride salt crystals. So we've got these crystals here, it looks like a little cube. Here we go. The sodium cations, Na+, is held in place next to the chloride anion. So we have positive and negatives. We got the positive purple sodium and the negative green chlorine by electrostatic attraction. This does not conduct electricity because the cations and anions cannot move. Whoops, I didn't mean to cross that out. I just wanted to underline it. Jeez. Cannot move. Okay, so remember, electricity spelling, man, equals moving charge. Spelling is so hard. Okay, that's solid. What about dissolved sodium chloride? When dissolved in water, the crystal dissociates, not entirely sure what that means, into the cation and anion. This conducts electricity because the charged cations and anions freely move around. So it looks like it's broken apart here, so I'm going to take a guess and say dissociate means broken apart. So next time you break up with a girlfriend or a boyfriend, you can say, we need to dissociate. I'm done with you. So, vocab. And then they'll be like, what? And you'll be like, that's why. Okay, what's this say? While each reaction produces a different crystal made up of different elements, all ionic crystals have several similarities. First, each crystal is highly stable and non-reactive, indicating that all atoms in the crystal have a full outer shell of valence electrons. So they all have their octet. Second, each crystal is made up of two parts, a cation and an anion. Remember, the cation is the metal, and the anion is the nonmetal, usually. Since the crystals are made of two types of ions, they're called ionic crystals. So you got the ion part. Cations and anions are held firmly in place inside the ionic crystal by electrostatic attraction. See how it's italicized? That's probably a vocab word I should know. Between positive and negative charges. Since positive cations are always next to negative anions, the crystal forms a regular pattern structure known as a crystalline lattice. Right, so we've got like positive, negative, positive, negative, positive. So next to the positive, it's surrounded by negatives. Because if you had two positives next to each other, they'd repel each other. And the negative is always surrounded by positives. See? And then there'd be a positive right here. So they completely lock in and attract each other. Ionic compounds are always solids because the forces between ions are so strong, right? The intermolecular forces, back from our phases reading. Third, each crystal conducts electricity only when it's dissolved in water or melted. Okay, why is that? A compound will conduct electricity if a charged particle, such as an electron, cation, or anion, is free to move. I already reviewed that. I'm so on top of this reading. And carry an electric current. When an ionic crystal is dissolved in water or melted, the cation and anion dissociate or break apart, which allows them to move freely and therefore conduct electricity. Solid ionic crystals do not conduct electricity because the cations and anions are locked in place in the crystal lattice structure. Okay, so solid does not conduct electricity. Okay. Alright, you should start trying to fill in the blanks on the next page, and then we'll discuss that in your groups. Come prepared, come with your organized stuff, and I will see you in class.